Good evening, and today we are the Genius Ones, and our project is the Health Outpatient Monitoring Equipment, and my name is Nichelle'Le Carrington.
I'm Bobby White.
I'm Jasmine G.
And I'm Petroleum Marshall.
Just a brief introduction. Our objective is to develop and produce a wireless system of sensors in a low-powered network that will be able to monitor and record a patient's vital signs for a convenient, low-powered, and lightweight portable device that can be worn on the patient's body. We aim that this sensor network be able to be worn on the wrist. That way it's portable, it's not a heavy weight on the person, and that it's able to record the vital signs at home versus coming to a doctor's office or a nurse coming to you, which will reduce the price in healthcare and also give a more efficient healthcare diagnosis when it comes time to go to the doctor because you've already monitored your vital signs beforehand. Just an overview. We plan to present the motivation for our project, the requirements, specifications, our design, especially our concept fan, the level 2 block diagram, and the Zigbee itself, which is the device that we will use for this, and our communication within the Zigbee. And also we will give a test demo at the end of our presentation. The motivation for this project comes from the needs of a lot of people with ongoing and chronic diseases that have to have at-home care. They're not able to go, it's not an inpatient type situations where you may have diabetes or elderly care or the outpatient after a acute surgery of some sort. And this will help reduce the price of healthcare for those outpatients and also give doctors a better sense of the diagnosis needed for the patient because they have been monitoring the vital signs throughout the whole process versus when something happened, you come to the doctor's office then. And another thing that we're interested in is the Texas Innovation Challenge, where we will develop our project and submit it to be in the research conference for this. And the competition is basically to use Texas Instruments products and design application of some sort. Ours is health in this case, and we also are looking for a microcontroller for Texas Instruments to incorporate in our design.
All right, the requirement specification. Each engineering requirement, you have to justify it. And in front of each justification, there's a marketing requirement also. 1 through 6 lists the different marketing requirements. 1 should rely data from sensor. 2 should be easy to use. 3 should be easily maintained. 4, the product must have a low cost. 5, should be reliable. And 6, should be durable. 1 engineering requirement, the device must sync data to a central control system. And to justify that, the general purpose of the project is to rely information from multiple medical devices. Just one of them. This is our design, the concept fan. The health sensor network branches off the 3 different elements, which is the sensor, the virtual signs, and the health report. The sensors, just to name 3 of them, the pressure sensor, the scale, which is weight, and the blood glucose meter. That's what we'll be using for the sensor. Also came with, the Zigbee came with a gas sensor and accelerometer sensor. The vital signs, we're going to do pulse, deal with the oxygen, the blood glucose level, blood pressure and weight. Health report, where you can do SMS for cell phones, notification, emails, or voicemail. Okay, this is our design. These 3 networks are, you have the star, the cluster tree, and the mesh. These 3 are different types of networks that you can do with the Zigbee device. It's built upon the IEEE 802.15.4 standard. Zigbee added both routing and multi-hop functionality. Star networks are well peer-to-peer mesh and cluster tree. ZigBee networks and dynamics, scalable and decentralized. These qualities and more make ZigBee an excellent technology for applications like home, industrial automation, medical monitoring, and HVAC control.
Okay, so here we have a level 2 block diagram, which consists of analog to digital converter, our ZigBee device, control center, our radio frequency transmitter, which would be our ZigBee device, microcontroller, and memory in the form of EEPROM. And here's pretty much the diagram seeing the data flow and how it works together. Here we have our Gantt chart pretty much outlining the processes and the amount of time we pretty much want to lay, put into each part of the design. And you kind of see how we move forward through that process. As far as communication goes, we heard before about how we'll be setting up our wireless communication, our wireless sensor network using ZigBee protocols. And we'll be using ZigBee itself to create the wireless sensor network. So it'll be all ZigBee protocol. And the idea behind using ZigBee is that it's low power and they have a deep sleep mode to save more power. So we're going to be monitoring patients pretty much continuously. So it's important that we're not spending a lot of energy, which kind of, converts the cost. We'll have our actual wireless network communicating ZigBee to ZigBee. We'll get the data from our network to a smart device via a gateway and Wi-Fi. That's pretty much it as far as the concept of our communication.
As you can see, this is our test document. This shows a systematic approach that we plan on to test our demonstration that will be going on shortly after our presentation. We will be testing the ZigBee sensor module to smart device connection. And the way that you do this is we have a set of steps that we have shown on our test document, and we have to make sure that each expected output represents correctly based upon the action. This is our current cost table. We have 4 essential devices. This is not everything, of course, but 4 important things that we need toward our project, one being the pulse and oxygen blood sensor, the eHealth sensor shield, the body temperature sensor, and blood pressure sensor. These are a few things that we plan on incorporating in our project, and it's a summary of what the cost will be, and as of now, it's about $310.
In conclusion, our project is aiming to reduce health costs and also to reduce the risk of outpatients misdiagnosis. And our project will also be introduced into the Texas Instrument Innovation Challenge, and we also aim to use ZigBee to ZigBee communication within our network to transmit the data and to receive the data via Wi-Fi to a smart device such as a smartphone.
So let's talk more about the device you're gonna design. You're gonna have one patch, right? Just one.
Yes.
And you're gonna monitor all the vitals signed on that one.
Yes.
So you talk about blood pressure,
Yes.
pulse,
Yes.
oxygen level.
Yes.
What kind of sensor are you gonna use that you can observe the oxygen level patch?
It's more of the oxygen saturation within the blood, not the oxygen level. And we were looking at pulse oximeters to see if we could find a sensor using that. I know with pulse we would use either the accelerometer or the pressure sensor for that, but the oxygen is more of the oxygen saturation within the blood.
So you're gonna need a pump or something for blood pressure?
We're trying
Yeah. Well, pretty much, it still works the same way as you would be doing it manually, so you wouldn't need the pump and the strap and the whole thing. But the goal is to find something as small as possible that won't be as constricting. So the idea is that the person is still mobile. I found we found a couple different examples, but the smallest that we found is on a little bit on the expensive side. So just for the sake of getting the project together, it'll most likely be something a little bit larger than what we intended. But we found some available devices that work as far as blood pressure.
So what's the data rate, like data sampling rate for your device?
Right now, I can't say exactly what it is, but it's at the default for the watch modes that we got. So I haven't changed that part. I haven't worked on pretty much performance-wise, but what I've been doing was just trying to get information going back and forth to where I need to go, as far as the sensors and the wireless network.
So I mean, like for different wireless sites, you're gonna need a different sampling rate. So you're not gonna be able to measure the blood pressure every 1 minute, right? So you cannot pump something every 1 minute. So what is the?
Oh, that's what you okay.
Yeah.
On the measuring side, okay.
So what have you decided? Like how many times you're gonna measure the oxygen? How many times the blood pressure? Are they gonna be all the same, or you're gonna have different sampling rates for different vital signs?
Well, the goal is to have them different because your heart rate has the ability to change faster than your temperature might move. So the idea is to pretty much see like industry standards, not industry standards, but medical standards as far as how the body reacts and how fast you might need to check those things.
So that makes sense. I guess you don't need to have the different sampling rate for all of them. But if you don't have different, if you're gonna have different sampling rates, have you think about how you're gonna incorporate all of them in your device? So if you have different type of data with different rates, right? How your device is gonna handle that?
I think that could be something that we could test in the future, like another demonstration or something like that.
are also alternating the times that they're taking. That way it won't be a collision
That'd
of
be
the
a
data.
programming.
It's the time and also the type of data. So for for oxygen level, you're gonna have some digit numbers. For blood pressure, you're gonna have like a upper limit, lower limit. So it's kind of a different number. For pulse, it's different. Sometimes the number are digits, sometimes are analog. So you're gonna have different type of data with different sampling rate, right? Okay, so it's something you're going to address in your device. So let me ask you another question. So you're talking about connecting Zigbee to Zigbee. If you're just going to have one patch, why would you need that?
Okay, so for HF4, we also have scale up here. We can't necessarily measure their weight just from their wrist. So it'll be just for the weight scale, really.
Okay.
we had in mind what other things we might want to measure, but the idea is that we can at least incorporate the weight.
So like basically you're going to have two different kind of communication, Zigbee to any smart device and Zigbee to Zigbee.
Yes.
Okay. So what are the sensors that you have right now?
Right now, as far as sensors, we pretty much have temperature and pretty much environmental sensors. So we're able to capture information from the room. So as far as particular on patient, by actual device, we don't really have the exact sensors we use. We're still trying to figure out exactly which ones work the best for particular boys. Yeah.
So it's like we are testing the communication system today,
Yes.
right?
Yes.
Simply
Okay.
just wireless.
So when you think you're gonna have your sensors, your own sensor,
Hopefully by,
order them?
no, we have not ordered them. We're still trying to locate the actual sensor. Because we will find the device, but it's not a sensor. And you'll find, say, a blood pressure for the wrist, a blood pressure monitor for the wrist, but it's not an actual sensor. And when we're trying to locate the sensors from the papers that we've had, they don't specify the sensor's name or the brand or the type. They'll specify what sensor they use, like say a accelerometer, a laser type accelerometer, infrared sensor, or the gas sensor. So that's our biggest problem right now, is actually locating individual sensors and not the devices that they're
So you
used
can find
in.
the safe sensors for Buddy's DP website. Have you tried that?
From
There are
Which
list
website?
of sensors that we can use for human.
what website?
Zigbee. The Zigbee is from that website.
We saw that, but they were more devices, and we were like, can we get these?
They also have a sensor. So have
Okay.
you tried to call them or email them and ask for specific information you're gonna need? You can even
not
email
Zigbee.
the authors of the paper you're talking about. So
Okay.
you usually get response back. So.
Oh, okay.
Okay.
Well,
Okay.
So we can do that today.
So in your final project, okay, what are the exact devices you're gonna have? So
We're aiming for pulse ox, which is the oxygen saturation level. We're aiming for blood pressure, and we're also aiming for weight. And
But we're back and forth between body temperature and weight.
yeah,
okay.
because including a scale may take an extra step, whereas adding a sensor might just be
And it might be expensive. So what's the total budget you have? You have
500
right? And you have 200
from Texas Instruments.
You're gonna spend it for IC. How are you gonna incorporate that license? The IC is from Texas Instruments.
We're waiting on their response currently, but we were looking more at the microcontroller from them.
Okay.
Because for the competition, you have to have one of their microcontroller plus an extra device. One other device, it can be a sensor, it can be just another device from them, another part from Texas. You have to have two, but
So maybe you may
microcontroller.
even have a chance to contact them and see if they have a sensor or something.
Okay.
We viewed the website. They have sensors.
There was one that, the microcontroller, that we saw that is for health.
So if you need to order them, you need to do it fast because you just have like the right. Okay. And you're gonna have one Zigbee.
Right.
Because I guess you won't be able to afford the scale.
Yeah.
Have you checked on the price for a scale?
We saw one on Zigbee, but it didn't have the price next to it.
You're in possession of that, right?
Yeah. And they have their company, but it's like you have to, they just tell you that the name of it is and who it's by, but they don't really give you a lot of other information when we looked on the zigbee.org.
So I'm pretty sure if you contact them, you're gonna have a better idea than
Okay.
this one. Okay, so you had, it's hard to read, I think it's